Hello, good afternoon. This is Waidaka Simon again on this live stream. I want to welcome you to our live stream today and invite you to journey with me in this live stream as we discuss matters that are related or how we usually generate perspective drawing, especially in technical drawing. So I want to welcome you, be with me in this session so that we really be able to understand how perspective drawings are done and we see the concepts behind perspective drawing. In case you have a comment, just post it on our comment section as this live stream goes on, so that in case of any question, I will be able to respond to it. Having said that, today we look at generation of perspective. We'll see what perspectives are. We see the different types of perspectives that are there, so that we'll be able to understand. And finally, we'll look at how we can generate a two-point perspective. Perspective drawings are commonly used in technical drawing to show an item in 3D on a 2D page. So we'll be showing an item in 3 dimensions, but of course in a 2D platform or page. And therefore, perspective drawing show an object in 3D getting smaller in the distance. So as we will witness is that whatever object we'll be representing the size will decrease as distance increases. Therefore, that is what we'll be doing, just to generate a perspective of a cube, just a simple perspective of a cube. Therefore, let us see the various types of perspective drawings that are there. So we have 3 types of perspective drawings, that is 1-point perspective drawing, 2-point perspective drawing, and 3-point perspective drawing. So we will be able to maybe see the difference between the types of perspectives that are there. But majorly for this session, we'll basically look at the major difference between 1-point, 2-point, and 3-point. But we will concentrate more on 2-point perspective. Therefore, again, in perspective, we have various terms that we use, and we have what we call the ground level. We usually have a horizontal line that denotes the ground level. We also have another line that is in between the ground level and the picture plane, which is known as the horizon level. And finally, we have the picture plane. So ground level is basically where the observer usually is positioned. Horizon level will give us the center of vision of the observer, or the vanishing points for the perspectives. And the picture plane is a plane that is used to reference the object that we are drawing perspective representation of. So therefore, for this case, we'll be doing a perspective of a cube. Therefore, we will reference the plan of the cube with picture plane, and then we'll be able to generate the perspective of that cube. So whenever we are generating the perspective, we usually use the plan of whatever figure or whatever object that we are given. So far we've looked at a number of things. We've looked at what perspective drawings are, and we said they are drawings that are used in technical drawing just to demonstrate 3D objectives in 2D dimension. And we've also seen the various types of perspectives that are there. We've talked of 1-point perspective, 2-point perspective, and 3-point perspective. And we've also seen how a layout of generating a perspective is usually organized. The ground level, horizon level, picture plane will always be organized in that manner, where the ground level is where the observer is positioned, and then we usually have the horizon level, that is where the center of vision of the observer is usually located, and then the picture plane is used to help us reference the given object in relation to the picture plane. So therefore, we'll always specify where the object is with respect to the picture plane. Maybe 20 millimeters above the picture plane. Maybe the object is lying on the picture plane. So those conditions will change from one point to the other. Again, we've said when you are generating perspective, we usually use the plan of the given object. That is what you usually reference with respect to the picture plane, and then from there we go ahead and generate the required perspective, whether it's a 1-point perspective, 2-point perspective. So, and for this case, we'll deal mostly with 2-point perspective for this session. So therefore, let us see further how the perspective are also organized. 1-point, how is a 1-point perspective organized, and how is a 2-point perspective organized. So when we talk of a 1-point perspective, maybe I can just separate this so that we see the difference between the two. You see the difference between the two. When we talk of 1-point perspective, we are basically saying that we'll have the ground level positioned at the lowest point of our drawing paper. Then we have the horizon level, and we have the picture plane. And the distances between the ground level, horizon level, and the picture plane will always be given. You'll always be told where they are positioning, and then you'll always be given the eye or the center of vision with respect to the object. You'll be told where the object is positioned with respect to the observer. That is point E. E will stand for the eye or for the observer. Then we have CV stands for the center of vision. So in 1-point perspective, we usually have center of vision, so that whatever object we are drawing, all the lines will recede towards that 1 point. That is the center of vision. All points that are for if you were to draw a cube, then all points will recede towards that 1 point, that is of vision. So that point will end up there, this point will end up there, this point will end up there, and then we will just complete the cube. This is just a sketch. I'm just sketching how we generally see a 1-point perspective. So this is just a sketch, a demonstration of how a 1-point perspective would look like. Of course, we have the inner lines. Definitely this should come there, and this should come there. Remember, this is just a sketch. I'm just sketching. I'm not using any whatever. So we would see it in that manner. So in 1-point perspective, we only have one center of vision, and all the lines will recede towards that point. That is the center of vision. So again, as we've said, the horizon level, the picture plane, and the ground level will always be given, and you'll always be told where they are positioned So therefore, again now with a 2-point perspective, the arrangement is different. 2-point perspective, you'll always be given the positioning of the picture of the pran, you'll always be told where the pran is and at what angle is that pran. Maybe it could be 45 degrees angle, could be slanting at 45 degrees angle or 30 degrees angle, depending with the requirement of the question. So with respect to the angles that we are given, then we'll generate the vanishing points using the angles given. So if now at this point is 45, both the angles are 45, so we will generate from point E, we will draw a line at an angle of 45 until it touches the picture plane, and then drop it vertically down until it touches the horizon level to generate the right vanishing point. So I'll repeat again. If the plan is inclining at an angle of 45 degrees on both sides, because of course it has to be 45 degrees so that at the angle for the plan is 90, which should give us 180. Therefore, we will generate our perspective, our vanishing points. Remember, is a 2-point perspective, so we have the right vanishing point and the left vanishing point. So therefore, depending with the angle of the plan, the inclination angle of the plan, that is what we will use to generate our vanishing points. So for this case, assuming this angle is 45, then we'll draw a line from point E at an angle of 45 until it touches the picture plane, and then we'll drop it vertically down to give us the right vanishing point. Then we'll do the same on the left hand side, draw a line at an angle of 45 degrees until it touches the picture plane. Then we drop it down until it touches the horizon level, and that's where our left vanishing point will be. So in case the plan was inclining at an angle of 30 degrees on one side, therefore the vanishing point maybe to the right will be generated at an angle of 30 degrees, and then the left one of course will be at an angle of 60 degrees, so that 30 and 60 plus the right angle for the plan will give us 180. So that's how we generate the vanishing points. But the vanishing point will always be positioned on the horizon level. Remember, we said the horizon level is where the eye of the observer is usually positioned. So all our vanishing points, right and left vanishing points, will always be positioned on the horizon level. Again, before we move now to an example of how we can generate a 2-point perspective of a cube. This is how the organization is, and this is how the question would appear for us to be able to generate the perspective of the cube. We've seen how the ground level, the horizon level, the picture plane, the plan 60 millimeters from the spectator, point E denotes the spectator, CV is the center of vision. We've generated the two vanishing points at 45 degrees, both to the left and to the right, and therefore we can proceed and now start generating the perspective of the cube. So for us to begin generating the perspective of the cube, first of all, we will consider the line that is inclined towards the spectator. The line or the edge of the plan that is inclining towards the spectator, which is edge BC, we will consider that edge, and that is where we will begin from. So we will extend this line, we will extend line BC, until it touches the picture plane, and then we will drop it vertically down. Let me just change the color so that we are able to follow. We will drop it vertically down. We'll drop it vertically down until it touches the ground level. Once it touches the ground level, that point will not be point B, simply because the picture plane is placed above the horizon level. Simply because the the plan is positioned above the horizon level, then once we protrude line BC and then we take it to the ground, it will not give us point B. We will generate point X. We will generate point X, and then point X we will recede to the right vanishing point. Point X will recede to the right vanishing point. So we'll draw a line from point X. We draw a line from point X up to the vanishing point. Up to the vanishing point. Therefore, then we will take point B. We will take point B and reference it with point E. We will draw a line from point B, referencing it with point E. Maybe I can change the color for that line so that we also are able to follow. Maybe I can use black. So that line is a reference line from point B to point E. Then where that line cuts the picture plane, we'll draw a horizontal line that goes down until it cuts the one that is coming from point X. So for us to generate point B, we will reference point B with E. Then where that line cuts the picture plane, we draw a vertical line downwards until it cuts the line that is coming from point X, and then we will generate point B. We'll have now generated point B in perspective. We'll have point B in perspective. Then again, that point, we can see it has already receded to the right vanishing point. So again, now we take it to the left vanishing point, because this is a 2-point perspective. So every point has to recede from to the right and to the left vanishing point. So B goes to the right vanishing point and it also goes to the left vanishing point. So we now have point B in perspective. Then we do the same with point A. So we will reference point A with E. Again, I use a black line to show our reference line, point A with point E, which is the spectator, because it's the spectator observing point B. And then where that line cuts the picture plane, we again draw another line horizontally down until it touches the line that is coming from point B. And that will give us point A. That will give us point A in perspective. So for us to generate point A again, maybe I can just recap for the same. We will reference point A with E. Where that line cuts the picture plane, we draw a horizontal line until it touches the line that is coming from B. And then we will have point A. Then point A has receded to the left vanishing point, and therefore it has also to recede to the right vanishing point. It has to recede to the right vanishing point because it's a 2-point perspective. Then we need now to generate point C. And for us now to generate point C, we'll just do the same as we've done with point B and point A. Again, with a black line, we reference point C. We reference point C with E. Where it touches the picture plane, again we draw a horizontal, a vertical line downward. We draw a vertical line downwards. And where it cuts the line that is coming from B, because remember point C is on the same plane with the B. Point A is coming from point B. So therefore, you can notice that point B is generated, point A comes from point B, and now point C comes from point B again. So we can note that point as C. So this point now becomes our point C, and therefore we can we are already seeing that point C has receded to the right vanishing point. So again, we need now point C to take it, or it should recede to the left vanishing point. So from point C again, we draw a line from C to the left vanishing point. And then basically you'll notice that the interaction between the line that is coming from point C to the left vanishing point and the one that is coming from point A to the left vanishing point will give us point D. So therefore we've already established point D. So that is our point D. And then now we already have generated the perspective of the base of the cube. The base of the cube in perspective. And maybe I can just highlight it. Maybe I can use red again so that it's a little bit visible. Sorry. And that now is the base of the cube. Therefore, again, we know we are dealing with a three-dimensional figure, which is a cube, and then therefore it has a height. So we will measure the height of the cube from the point that we generate, that from the line that gave us point X. That will be our height line, the one that we generated first from point B and gave us point X. That will be our height line, and that's where we will measure the height of the cube. And for this case, the height of the cube is basically 50 millimeters, because we are generating a cube that is 50 millimeters. So I'll just measure 50 millimeters from point X. Just measure 50 millimeters from point X, and that will give us the height of the cube. And what we'll need to do is to reference or to transfer this height to the line that is coming from point B. From point B to generate point B there, we just transpose that height until it touches point B. So this will give us, maybe we can use small letters. This will give us point B. That will give us point B. And then B will require to ensure that B recedes to the right vanishing point and it goes to the left vanishing point. So we will draw a line from point B to the right vanishing point. And then we'll also draw a line from point B again, from point B to the left vanishing point. So those sides will always recede either to the left or to the right. And maybe I can delete this so that we can see clearly how the perspective is coming out. And from those two lines, now you can tell that we already have point A and we already have point C because they are vertically above each other. So we've already established point A. So we give this as point A, and then we'll have this point is above point C as our point, denoting it with small c. That will be point C. We can just put it a little bit closer for us to be able to see. Therefore, we have point C, we have point A. So what we need to do is to ensure that A recedes now to the right and C recedes to the left. We just draw a line from point A, and then we draw another line from point C, and it will give us now the top face of our cube. And maybe I can just highlight it again in red. So that it's a little bit visible. Sorry. Just get the points clearly. So then we have the bottom and the top part. And then again, you can notice that point D is already now established because D is basically vertically above the D that is generated by the top or the top face of the cube. Then we can denote this as point D. Basically, you can tell that our cube now is almost complete. What we need is to outline the edges, the vertical edges. Again, I'll use a red line to just complete. Just so that we are together. Just need to outline those lines, and then of course we have now D, which is basically above point D, and maybe these ones I can we can just use a different color there to just demonstrate the inner lines of our cube. And that's how we generate perspective, a 2-point perspective of a cube. That's how we generate a 2-point perspective of a cube. Maybe just as a recap or an overview of what we've done, maybe very quickly. So what we did first, we extended line BC until it touched the picture plane. Then we dropped it down to get point X. Then we took point X to the right vanishing point simply because we used line BC to generate point X, and it's slanting towards the right hand side of our perspective. So therefore, point X will recede to the right vanishing point. Then we generated the bottom part of the cube by referencing point B with E. Then where that line touched the picture plane, we dropped the line vertically down to get point B. And the same case gave us at the top point B. Then we also referenced point A with E, and when it touched the picture plane, we drew a line vertically down and it gave us point A. Then we did the same with point C. We reference C with E. Then we draw a line until it touches the picture plane. Then we drop it vertically down and it gave us point C from the line that is coming from point B. And of course, then taking C to the left vanishing point and point A to the right vanishing point, we got point D. Then we measured the height of the cube on our height line. That is the line that is coming from point X. That is where we will measure our height line. So if it's 50, we measure 50 from X, and where you get 50, then you transpose that 50 towards the line that came from point B, so that you generate point B. That is the top face of the cube, and then that point recedes to the left and recedes to the right, and of course you have established point A and point C. Then again, completing by projecting or by extending point C to the left vanishing point and then point A to the right vanishing point, then that will automatically give you point D, and then you just outline your cube to show or to complete the generation of the perspective in or the perspective representation of the cube, which is positioned 20 millimeters above the picture plane and again inclined at an angle of 45 degrees. So I hope this live stream has been maybe informative. You've gotten the concept behind perspective drawing, and the same concept is employed in different shapes, in different objects, and you are just able to generate the perspective. The most important part is to note in a two-point perspective is that all the points will recede to the right vanishing point, and again they will recede to the left vanishing point. And of course, then we join up the whole figure by use of vertical lines. So that brings us to the end of our live stream this afternoon. You can visit our playlist and see the other various types of perspectives that we've done. We have tutorials on the same. This was just a simple one, so you can check in and see other types of perspective drawings